So thank you all and welcome to this webinar, be you on Zoom or LinkedIn Live. I've made my code open. Now what the steps to a thriving open software project. I'm Summer Rosanowski, the Community Outreach Officer at Europe PMC, the Life Science Database. And today I will be interviewing a panel of EMBL staff to find out their experience working with the open source code as part of the Capital project. And this is an open source tool that uses machine learning to identify biological concepts from text and link them to relevant ontologies. They will discuss the challenges they have encountered and potential solutions to address these. We have 4 speakers joining us today. We have Santosh Tiriani, the Senior Machine Learning Developer at Europe PMC, Melanie Volmar, the Arise and Marie Curie Fellow at PDBE, Nicholas Bosk, the patent data scientist and informatics expert from SureChEMBL, and Ines Smith, the safety data scientist and information from SureChEMBL. So for today's webinar, our speakers will each present and give us a short presentation about their project. Following that, we will have a panel discussion where I will be interviewing our speakers, and then we will follow that up with a Q&A where you can ask us your questions. Please do remember to use the Q&A rather than the chat, and also for those on LinkedIn Live to put that in their chat there. So let's get into this webinar, and I will hand over to Santosh.
Thank you, Sama. So I'm a senior machine learning developer working in the literature services team in EMBL-EBI. So yeah, let's dive. So the literature services team also runs the Europe PMC project, which is a life sciences literature repository. So we have we partner with PMC, and we have more than 44 million abstracts indexed within our repository, which includes PubMed, preprints, and also agricultural records. We index 32 preprint servers, and we have more than 765,000 and counting preprints indexed daily. And we also have 9.6 million full text articles. And we have more than 60,000 full text preprints. And also we are funded by more than 33 plus funders. So we are not only just a life sciences repository for scientific articles, we also do something extra. That is, we have an annotations platform where we also extract information of interest from these scientific articles. So such as the biological entities, like gene proteins, chemical drugs, diseases, cell lines, pathways, and then we put them into annotations platform and make them available through our annotations API. So we also have built a community out of this annotations platform where others can also submit annotations, and researchers, librarians, pharmaceutical companies, whoever is interested in extracting biological evidences can use our APIs to extract that information of interest. So right now, what we were doing is with dictionary-based outputs to extract the annotations. And then we decided, oh, let's move to machine learning, and we can get use of AI-based techniques to extract the information of interest. And that's when we started thinking of coming up with a contextual annotations pipeline for tagging and linking. Tagging the information of interest, that is the biological entities, and also linking them to knowledge bases. And that's where we introduce you to Capital. So in Capital, we have 3 main functionalities. One is generating datasets. So we use Europe PMC to Articles API to download the articles, and then we can use the annotations API to extract existing annotations and then convert them into machine trainable formats. And then you can train your machine learning algorithms on them. And then the ML entity tagging part will provide you with the code to train your own machine learning algorithms using Hugging Faces models, and then also do hyperparameter tuning using weights and biases. And then the linking part will help in linking the extracted entity with the knowledge base of your interest. So within this capital, when we started working on this, we started as open source first, and Nicholas joined and helped collaborating with the weights and biases, and then Ines helped me with generating the data sets, especially for the experimental methods, and Melanie with standardizing XMLs and helping me with knowledge linking. So we all contributed to this project together, and with this collaboration and contributions, we have a package now. Thank you.
Right, that's over to me. So yeah, I'm an ARISE Marie Curie Fellow, positioned in the PDBE team. So PDBE is everything about experimental protein structures, and now with AlphaFold-DB also with predicted models. And what my work usually involves is looking at the literature as you have it in Europe PMC, as Santosh just mentioned, and look in the literature and see if there are any mentions of particular residues that are in a protein or predicted or experimentally determined that I can map to a structure, and therefore sort of link up what is in a publication said about a residue in a structure and where it actually is, and whether it has any support from experiments. Right, so basically what we've got is on one side, we've got a literature that when an author publishes something, they put lots and lots of effort into writing detailed descriptions and providing beautiful pictures where they look at the individual residues of a protein, and they discuss their theories about it and functions. And then on the other hand, we have databases where we curate all of that information in there. So there you go, I just highlighted that. So what normally happens is that you have a person, a biocurator who sits down, reads that paper, and scribbles down somewhere all of these beautiful details, and then feeds them into a database. So once we've got that knowledge in there, this is then obviously in a machine readable form. So if it's stuck in a PDF or in an XML even, in a paper, you can't do anything with a machine with it really. But once you've extracted it and put it in a database, you can access it with an algorithm. So the idea is that you take the information that's been manually created, train a transformer or some other machine learning model, and then basically let that machine do the reading and extraction for you, and then continue increasing the content of the databases. So that's exactly what we have. That's sort of what I'm trying to do. And then the biocurator is basically the control mechanism of the machine, and can just go over what the machine has extracted or go back to the paper and do some cross-reading and identify whether it makes sense or not. And that's sort of the main purpose of my project. Now, if you want an application for that, so here we go. We've got our paper. So it's not just theory and it's not just a model. I've actually got it in an application. And that is an aim to try and combine not just the publication text, but combine it with some tools that guide, in particular, reviewers who read structure papers. And they normally have an awful lot of different windows open to assess whether the statements an author, a researcher makes in their publication is actually valid and is supported by the data, by the structure they've produced alongside. So we've got these two inputs, and we stick it into our magic box, and we let it shake and we let it run, and then there we go. That's the output that we get. So we've got now the publication with the structure viewer embedded. So if you click on the residue that's highlighted here in the paper, Then you open up a structure viewer that positions the molecule on the residue it's talked about. So here's the glutamate 944. And you get validation statistics. And so basically, you've now made the link between the experimental structure, or it could be a predicted structure. And you also have to the mentioning in the text. And additionally, on the background, we also link it up to the reference structure in UniProt. So that's the entire work.
Hi everyone, so my name is Nicolas Bosch. I work on the SureChEMBL project, which is a database of patents and that we annotate with chemical but also biomedical annotations. Brief introduction of what is SureChEMBL. So it's a database of annotated patents. And it's important to read patents when we do science because they contain a lot of knowledge about, in particular for chemical information, that's our interest here. Information that does not appear anywhere else or with a huge delay. And this information can be about the compound structures, but also about biological targets, diseases, and indications. So in this database, we have 177 million patents, 28 million of them are chemically annotated. From that, we extract almost 29 chemicals, and the number is growing every month. And more recently, we have introduced the biomedical annotations that are at the moment only generated on the fly when you open a patent in the SureChEMBL website. I will show you that my last slide. So we have an NLP model, which is generating annotations for the patent document. And this is an in-house model that was developed with the help of Santosh. A bit of story that we had an issue with a software provider who was initially offering a tool to generate these annotations, and one day we no longer had access to this tool. And at the same time, we had EuroPMC who was introducing Capital. We was not yet Capital, but there was a framework to develop an NLP model. And it was really the best approach for us to build up our own model to annotate the patents. So we reused a gold standard that was published, 200 fully manual annotated patents. We selected 4 annotation types. And using a model from Hugging Face that we validated, we were able to get our own annotator, which is now running in our production server. And the next work for us is to work on the linking part, linking the annotation to the ontology. That's also something that Capital can help us doing. And just to conclude on the next slide, just to give you a flavor of how it looks like when you annotate a document, it highlights a lot of information, and that makes the reading a bit more easier, in my opinion. So yeah, thank you, Capital.
Thank you, Nicolas. That really introduces well what I'm gonna share about our use case in the ChEMBL team. So I'm a data scientist, and one of the things that we are working on is annotating assay descriptions from the ChEMBL database to the Bioassay ontology. So on the next slide, I have a couple of examples of assay descriptions, and these usually describe a bioactivity of some chemical compound in a lab-based assay. So there is some description of that, and then usually it mentions a kind of experimental method, such as FRET-based assay or scintillation counting. And this is a manually extracted piece of text, and we would like to automatically annotate this with specific identifiers from the Bioassay ontology. So on the next slide, we have an overview of the workflow that we are developing to do this. So first, we have developed named entity recognition model that detects these kind of experimental methods or physical detection methods from the assay description. And then once we have those specific piece of string, we then submit, we would like to annotate them with the bioassay ontology. And we have been trying a few different tools to do this. And Capital is one of the methods. So on the next slide, we have a bit of overview how we try to reuse Capital. So Capital does the linking for a few different entity types, but we are the experimental entity type was not covered yet. So we made a few modifications to cover the new ontology, as well as some changes to the specific methods, because the Capital project is very focused on processing a lot of literature and high volumes. But in our use case, it's a bit smaller, and we are more interested in the accuracy over the kind of speed of the embedding. So we had a few modifications, but then we evaluated the method on a gold standard and were able to get some performance metrics for the performance of the linking. So what was really useful was that Santosh had made his project open source from very early on in the project. So we were able to quickly evaluate, like quickly reuse this code, that we could use this machine learning based method because we would really like to move away from the dictionary based methods. So that was really, really helpful for us. And in the process, we had some suggestions for the environment specification for the README to improve it. So hopefully that helped to also contribute back to Santosh's work. And possibly it provides, our use case could be a case of a use case for future expansion of Capital. And as we started kind of working together, we started exchanging some training data sets where we had some curated data. Then we found it was possibly useful for Santosh training and some gold standards. So it was really nice to start the collaboration.
Wonderful. Thank you to all of our speakers, Santosh, Melanie, Nicholas, and Ines, for the brief introductions. So for this next part, I've got some questions for the panelists. So my first question is for Santosh. I know you create open source code as a default. What was your introduction to open source software, and how did you start doing it yourself?
So my introduction really happened after my master's. So at that point of time, I was using open source codes, sorry, but I was not contributing to it. So I started contributing to it when I was doing my PhD in 2013-14. So the reason was I saw that the citations were increasing because people were already using my code and citing my paper. So I thought, well, this is good. And then I think from 2014 onwards, the editors as well started asking within the computer science domain, asking us to, like whenever we submit a paper, they also want the code to be online and reproducible. So there was a big issue on reproducibility and reusability. And that's when, it all started. And then when I moved, but at that particular point of time, I was mostly working on my work, on my evaluations, but I was not making it from the start as open source. So when I was submitting the paper at that particular time, I used to put it on to the GitHub. But everything changed when I started working for EBI, for EMBL. So the open source first started from here. So whenever we embark on a project, we start as an open source project. And this has actually really helped because, for example, I was struggling with hyperparameter tuning, and that's when Nicholas contributed to it. And then with I was only testing for 4 entities, and my entity linking was working very well on only 4 types of entities, but when Innis tested it, it wasn't working great for experimental methods. So it was very good, so that it's a win-win situation. So I was not spending much time on this, and I was concentrating on some other parts of the work, and I was also getting feedback asynchronously. So we didn't have even meetings, but then it was all working very organically. So yeah, so the main reason I shifted to open sourcing early on is I want the community to also to support the work I do, and also I want to contribute to the society, the community, and so that's the reason.
Yeah, that's fantastic to see that the collaboration helps the development of the code and improvements, as well as the citation impact as well. To follow up on that, Santosh, I'd like to ask you, what are some of the ways that the open source project is different from a closed sourced in terms of planning ahead?
Yes, so I can say there are few ways. First is the documentation. In a closed project, so because we are working within a team, we could have ad hoc meetings, and also we could go to that person whom we are working with and then have some discussions and then contribute to the closed project. When it comes to open source, what happens is we don't communicate directly like that, right? So everything has to be done asynchronously, and also people are working at different working times throughout the world. So documentation is very important. So with the right documentation, it will be easy for others to collaborate and contribute to the open source work. And then roadmap. Within a team, we would know when working on a closed project, like what are we using other tools like Jira or Trello. But when it comes to open source, the roadmap should be on the project itself, exactly using GitHub issues or whatever tools we use. And the roadmap clearly says where are we in the project and what are we looking for contributors to contribute to. And then how do we want to take this project ahead? So, and then licensing, this is important. From the start onwards, we should define a license so that other contributors who are contributing to it, they know exactly what they're going to achieve with this project. And then it can get tricky when you start integrating other third-party sources as well. So, so everything has to be open source. Projects that we link up or integrate to. And another important thing I want to mention is the data and model versioning. So with code, software development, it's only the code that we version. But when it comes to machine learning, it's not just code, but also the data and also the models. So we will have several models coming up. So when we do hyperparameter tuning, I generate 1,000 models with 10 different parameters. So we want to look for the right model, right? So all these models also should version, and probably when we have our requirements change, we will have to also redesign the data. So for example, let's say we have a data set with, let's say, gene, proteins, and disease as annotations. But for example, if we were to add experimental methods, so we add experimental methods to the existing data. So versioning of the previous data would help us to retrieve the previous data as well. And then we will have a new data that is version. And even with the models, we will have model 1 now and model 2.0 sometime later. So versioning of the models and data is also important. So in closed working space, what happens is these won't get released. But then in open, these should get released so that others also, they contribute if they want to know exactly what is happening throughout the project with data and models as well.
Thanks, Santosh. I can clearly see from that the transparency of kind of your roadmaps, your versioning, as well as the correct licensing and having that open source, how the documentation is all really important for that. So I know that, Santosh, when you started this project, you didn't know it was going to be picked up by others in the community. It didn't begin as a joint project from the start. And Melanie, you were the first person to pick this up. So I'd like to ask you how you heard about this project and why did you get excited about it?
Oh, how I heard about it is very simple. Santosh and I were working on the annotation project that I'd introduced earlier, anyways, and he just said, "Oh, how come you're not using my tool?" That's it. That was very, very easy. But it was actually so the two or the bit of annotation that the named entity project does at the moment is actually fairly straightforward because UniProt is a well-curated reference database and it's very easy to link UniProt PDB and annotations. However, the whole project looks into other types of annotations, and these are far more difficult with less well-maintained controlled vocabularies or ontologies. And so basically I needed a way of how I can sort of do annotations and the linking to references for this much larger amount of annotations that come out of the text, and do that in an efficient way, not having to define dictionaries or having to go to these individual ontologies and with a pretty please and asking them to add new terms, which I just discovered in my publications, and they are not in the standard vocabularies and ontologies. And that I thought was actually a good place where Capital could come in and to help me to actually fill that gap.
Thank you, Melanie. That's fantastic to see how the project could help with the challenges you were facing. And how about yourself, Ines? How did you stumble onto the Capital project?
Yeah, so I joined the SureChEMBL group, and before that, I had been working in a company using natural language processing. And so then when I joined, I was asked to work on the assay SureChEMBL, the assay descriptions. And through colleagues, I heard about Santosh project and about Capital. And so then I got in touch to see if his tool could help with our use case. Yeah, so it was very useful that we were obviously on the same campus and we could interact. So that really helped to kind of kickstart the knowledge about the project.
Fantastic. It's really highlighting how much networking and collaborating with people is really important for finding these opportunities. That takes me over to Nicholas. Could you please tell me a bit about your experience with Capital and what made it attractive for you?
Yes, absolutely. So as I briefly said during my presentation, for SureChEMBL, we were in these situations where we no longer had an annotator for our documents. And so we were here, we had our annotation, they were here, and there was a huge gap. And we needed something to fill up this gap. And at the same time, I remember this webinar organized on the same platform where Santosh was introducing the EuroPMC new gold standard and the NLP model derived from that. So it was really the right timing, and we got in touch with Santosh, and the collaboration started very quickly because first of all the code was open and it was documented to a certain extent, at least enough to start working with it. It didn't take us very long to train our old model and to make it available to the community. So really the fact that the code was open was a booster for our project.
That's fantastic. Thank you. So my next question is to all three of the contributors, Melanie, Ines, and Nicholas. So what made it difficult to repurpose this project to your own needs?
Well, one of the things we had is that we were obviously having a different ontology space. So we did have to index the ontology that we wanted. And the other thing is that the embedding choice was different. So for Santosh use case, it's more the high volume, but we wanted more accuracy. So Santosh was very helpful in adjusting those parameters to our use case.
Lovely. Thank you, Ines.
Yeah, I mean, for me, it was mainly the sheer amount of ontologies I needed. And they all came in different formats, different completeness. and it made it really tricky to just get them into a common set that I could just use with Capital. To be honest, I still haven't resolved it fully. It's and some are easier to use than others, but it's just the sheer amount of different variety within the ontologies and the different types of ontologies that made it really difficult.
Thank you for sharing that, Melanie.
Yes, for me also it was the format of my input data that was the main issue. I've used gold standard from the literature, and obviously it wasn't. Yeah, it was different format. Fortunately, there are a lot of open code that are available online that can be used for that, but it was not obvious at first how to do that, and also I wanted to say that it's not because the code is open that you can reuse it easily. I mean, there is obviously a certain knowledge that you need to have about the code and to be able to do something meaningful with it.
Yeah, thank you to all three of you for highlighting those challenges you faced, and that you can open source a project, have some documentation with it, and it doesn't necessarily mean you can use it instantly, and there's still some things that need working through. I think it's always really interesting to learn how others have come up with an unexpected use case for your software. Quite often you can't anticipate how others will repurpose your code. So Santosh, is there a way to make your software design more flexible so it can be easily adapted by others?
So I would say a modular pipeline. So for example, in Capital, instead of having a long sequential pipeline, we divided the project into 3 different parts. So generating data sets, model tagging, and then linking. So all have different all are different modules on their own. So when the project is divided into different modules, so others can come and contribute to one of the modules, helping project attain faster into production, something like that. And then also, for example, the merge requests, and also the mergers, the pull requests, the issues on the open source project would also help. So I remember the first issue when Nicholas was testing, because I tested it on the Mac, on the Linux computer, it wasn't working on Mac. So Nicholas had to create an issue, and then for him, he had to create the pull request as well to put it on the Mac, because I didn't use Mac. And then Ines also has created some issues, and that's where and then all this will help contribute to the open source project.
Yeah, that sounds great. It sounds like everyone kind of using that code helped develop that open source project further as well for you. So this question is for all of you. For this specific project, you all had the benefit of working in the same institute. So it was easier, I imagine, to learn about the work that's going on. But how do you go about finding relevant open source software in general?
Well, for me, the key is to handle communication and coordination, especially in a collaborative open source manner, is with asynchronous work, because it will help people to contribute at their own time and the pace. So, and then mostly we were managing with issues and pull requests. So for example, if an issue was created, then if I had time, then I was contributing to it. And then if already someone has found time to work on an issue they found, they would submit a pull request, and that's where all this was working. And Melanie was testing the Capital's linking part with the ontologies, especially with sequence ontology, and she submitted a pull request for sequence ontology. So initially we had only 4 ontologies indexed, and with help of Melanie, we had sequence ontology indexed, and with Inis, we also benchmarked the experimental methods Bioassay ontology. So this is how we are expanding the linking part, and also with different models for training, and also generating different data sets. So there is more to go. For example, we want to index, so we want to version the data as well, because we are generating more and more data sets. So important things to pay attention are clear documentation, and then defined processes, the modules, roadmaps, and communication tools. Everything, if it is on open source itself, then people can work asynchronously whenever they have time, and something like that.
And when you mention these communication tools that may help people find your open source software, do you have any examples that you currently use, or any ways you currently would share that?
Yeah, so for example, if on the campus we were using Slack or emails, but in a wider open source part, I think issues and issues and comments on the issues are the way of communication.
Thank you. And Ines, I can see that you've unmuted. Did you want to add about what you go about finding relevant open source software?
Yes. So yeah, I think like as Santosh is describing, the communication tools, the issues, and just having your project on GitHub just helps, because even Google will then find, if you do a Google search, sometimes you can find relevant repositories from GitHub. So that can help. But then I also usually in preprints or in scientific literature articles, there's usually a section around code availability, or and I usually check that, and that sometimes helps. And then also when reading other papers that might not be directly about an open source library, just checking the methods that they used, then helps discover other projects as well.
Fantastic. Nicholas?
Yeah, I just want to add up that I think that every field has their kind of influencers on LinkedIn who are sharing a lot of information that they read, and things are relevant for their communities. So yeah, that's also a place where to hear about open source tools for the first time.
Fantastic. Melanie, is there anything you'd like to add?
Yes, I mean, yeah, as Ines said, just searching for tools is usually quite a good way. What I quite like as well is when it's not just a GitHub repository that you can clone, but when you actually make it a PyPy package, and it can be pip installed, which I find really, really convenient. So if you provide that as your open tools, your open software like that, I think that's actually quite a game changer, because you make it a lot easier for people to install it and run it. And and obviously the usual candidates, like doing a Google search or knowing few domain-specific chat portals, and scrolling through, or keeping up with communities on LinkedIn or whatever. I mean, there are plenty of platforms where you can look at that. That's basically where I find my tools.
Fantastic. Thank you for sharing those places so that everyone listening can also find other ways to find open source. Again, for all of you, there's this common misconception that all developers lack communication or marketing skills to promote their work. Do you think it's important to showcase and share your own code, and how do you approach that?
Yeah, so what usually I do is put it on LinkedIn, share it on Twitter, Threads, and then put it on community which I follow. So I follow a few machine learning communities. I posted there also some Google groups, and also I for example in conferences, especially in computer sciences, you can go. For example, in a poster, when you do a poster session, you can put as in a poster link. And when you're presenting, you can always advertise. So that's where I do the advertisement. Yeah.
Fantastic. Thank you for highlighting the use of social media, conferences, and your institutes as well. Would any of the other panelists like to add to those?
I think what was nice about, or what was interesting about Santosh's approach, was that he decided to make the project open access really quite early on and already started sharing with colleagues and in webinars about the project, even though it was not fully finished yet. And this really helped kind of the uptake. So sometimes people might think, oh, I have to like wait until the project is fully finished and published and everything. But actually, even if it's not fully finished, it can already help to get people knowledgeable about it so they can approach you if they're working on something similar. So it just increased the length of time that you can network about the project.
Fantastic. Any other comments to add from Nicholas or Melanie?
Yeah, I mean, I think we are very lucky to work for an organization where communication is very important, and we have the chance of having all these webinars, meetings, congress organized on site where everyone, and not only scientists, but developers can also present and share their work. And yeah, it just is very hard to miss an information with all the how the information circulates around here.
Yeah, about the sharing of code, I think it pretty much goes along the same line as sharing data. And a lot of people don't want to make their data open straight away when they've collected it, which is almost like not opening up a software project as soon as you start coding. But on the other hand, if you do it right, then you still have ownership of the code or of the data. You get your unique identifiers, you put a license on it, so you can still say, this is my data. If you reuse it, I give it to you. Or if I give you the code, you can reuse it, I give it to you, it's all fine. But I still have the ownership. And I think a lot of people still forget that this is what you can do. There is no need to wait to the very last minute or just for the publication to actually release all of that information. You can put it out a lot earlier because you do have ownership of it.
Wonderful, thank you. So that's the end of all of the questions I have for all of the panelists, and I can see that already from LinkedIn Live and also here on Zoom, we've got some questions coming in. So I'm going to start with the Q&A session now. So I'm going to go to the first question from Bibu, who has said, I've developed a piece of code and shared it on GitHub, but I'm finding that while it's being used, there's not much ongoing development or contribution. How can I write code in a way that not only makes it useful, but also encourages others to contribute and develop it further?
Is it for me? Okay, so yeah, write the code in such a way that it's modular, put all the roadmaps, what the project is doing, and then advertise so that others who might find interest in your project would start coming and contribute to it.
It might help also sometimes you see on repositories also like an explicit invitation to submit merge request, or so can be just useful to say on your README or on your entry page that you are welcoming contributions or suggestions.
Yes, I've seen some repositories where they put all the contributors on the README so that it gives a bit of a star or a batch, something like that. So that will also help, yes.
I think what quite often helps is if you have really got good documentation and good examples, and also sort of I mean, Santosh already mentioned roadmap, but some sort of future plans. And then for the future plans, you can then ask for input. And you can sort of, these are design features I would like to implement. Do you think it's worth it? Do you want to contribute? And then maybe you get new ideas. But certainly if you write code and it's been used, or even a fraction of it being used, it may not necessarily be always clear what it is for. So one thing I really like is when people spend good amount of time in writing good documentation and putting actually examples in it how to best use it, and not just a standard README which just gives you the license and a few comments.
Also, license is also very important. So when the reader comes in, when he knows exactly what license he's getting into, I think that would change as well the perception. So they might want to contribute. So licensing information is important as well. Yeah.
Lovely, thank you. And I think where we touched on looking at documentation, that leads us on to one of our questions from LinkedIn Live from Owana. She said, thank you, everyone. I'm new to this topic, but I was wondering if the speakers have any tips for ways to document life sciences software to make it easy for others to use and contribute to.
So I generally, because I write in Python, I use a Sphinx package. So I make sure that all my documents are compatible with Sphinx, and then you can run it across and it creates you HTML pages that can be included in your package. But I also, for my packages, I maintain a read the docs website for each of the documents where I'm very detailed in what I put, everything goes in, including run examples. And yeah, it takes a bit of time, but again, once you've done it, it just compiles and you have it automatically done. There's a couple of commands, and then you're done with it, and then it's just a matter of rewriting a sentence and run that command again. So it's the first setup is the tricky bit, but there are default documents out there which you can just copy from, and then you can amend.
Maybe one thing for life sciences especially is that often we are bridging between software developers and then maybe biologists or biomedical experts. So like Melanie said, it's really helpful to have specific examples and use cases and maybe cover a few different personas, whether they are more biology oriented or more software oriented, that if the examples are more focused, it helps people to understand.
Fantastic, thank you. So then we've also had another question on LinkedIn Live from Saeed. How do you prioritize maintenance tasks in open source projects, when there is limited community support?
Yeah, that's a very good question. Yeah, maintenance. Someone has to come up and contribute in the maintenance project if someone is really interested and would like to use. So that's a tricky question. Yes. So because we all want to move away from one project to some other project, and that project would go to maintenance, of course, unless it is being used. So if someone wants to, that's the beauty of open source, is because it's available online already, right? So if someone really wants to use it for their purpose, then probably they should contribute to the original open source project, but not just download it and run it on their machine. That's when, the open source projects would thrive. Yeah.
Thank you, Santosh. Would any of our other panelists like to add anything, Melanie?
I think from the user perspective, what I've encountered a few times is that people get a bit unhappy if it takes me some time to respond to a bug report or whatever. But then that feeds back because it is open source. I'm not it's part of my job to write that code, but it's not everything I do. So which is quite often for everybody who works with open source software, that's the case. So the response time for me is probably much longer than for someone who's, I don't know, working in a commercial company writing code because they make money with it. And I think as a user, you also have to sort of expect that you maybe, or will reduce your expectations in my response time. Let's put it that way. This is not malicious or anything like that. It's just, as you said, prioritizing can be difficult because it's not just my job. I have other things that I need to do. And and if this is too slow, you can always feel free to take on that pull request yourself, so you can, or any bug fixes, not just report it, you can also try and fix it, and then someone on the other end does the review, and then we're both happy.
Thank you, Melanie. Right, so we've got another question on Zoom. So an attendee has asked, have you had any challenges in terms of licensing choice for your repositories? Do you try to be as permissive as possible, or are there any specific guidelines that you have defined or follow when applying licensing and considering attribution?
Yeah, good question. So we had internal discussion with the team, and most of our projects which are made open source will have MIT license, the standard MIT license. That's what we define it for the software packages that we put it online. So it's a standard MIT license. So And for data, which is open access, the data comes with CC by 4 license, something like that. So we use the same license when we want to make it open source as well from our end.
Thank you, Santosh.
So one of
Ines?
the things to pay attention there as well is that sometimes the underlying training data that is used in a project might have a certain license, or if there's any other packages that you've used. So sometimes you might need to carry over that license. So that's one thing to pay attention. Yeah, from the SureChEMBL group, we do always try to think about if the license is permissive enough to cover commercial use, because we have, both, academic, but also commercial users.
Thank you. Nicholas?
Yeah, so I wanted to mention something similar. I mean, at the EBI, we have the chance again that we try to make as much as possible our work open and accessible to everyone. So the consideration around the licensing are relatively easy. Obviously, we want to mention that it's our work, but we are very permissive.
Thank you. Got one more question that's come in. Perfect. So, hello, I'm a new scientist in the field, and I'd like to know what recommendation you would make me regarding the authorship of the code when sharing it publicly on GitHub. A colleague and I are doing the same thing for the analysis of protein simulations, but I'm afraid that the code will end up being used or adapted without referencing it. In addition, I'm somewhat uncomfortable with its commercial use by pharmaceutical companies, although I understand that it's something beyond our control. Any comments on this would be very interesting. Do our panelists have any advice, any suggestions?
I mean, in general, simply by making the decision that you open source your software, you accept that someone will use it for their commercial purposes. On the other hand, you have the opportunity to do that as well if someone else makes a code open source and you use it. So I understand where this comes from. You can't really track it, and then that's when you sign up for it. On the other hand, you enable development, and I've seen that in other research fields where people did not open source their software, and it went into a company, and the company tried to have a monopoly on it and just sell that package, and everybody was dependent on it, and essentially the data analysis workflows in this research field stopped, and they had to go back, start from scratch, redevelop the software in an open environment, and basically rewrite every function, everything you needed to do that analysis workflow, and obviously name it differently and write it in a way that you couldn't say it was just copied and pasted from the commercial company. But what it basically did, once people tried to commercialize on it and try to sell it as a software package, was that no research was done in that area. So in some way, yes, you can be worried about it, but on the other hand, you will stop research if you don't do it. And that's just the compromise you have to make, I believe.
If you want credit to the work you did, there are citation dots on the open source project page. So you can add the citation so that people, not only the papers or articles people would cite nowadays, they are also citing software. This is software citations. So yeah, so you will get credit that way as well.
Fantastic. Thank you very much. So I think it's time to wrap up now, as we're 1 minute away from 5:30. So I'd like to thank again our panelists, Santosh, Melanie, Ines, and Nicholas. It's been really great to hear your views and experiences, challenges you've faced, and why you still think open source code is the way forward we should be going with our software. It's been really great to hear from you all, and thank you to everyone that's joined us on Zoom and on LinkedIn Live and given us some really interesting and thought-provoking questions. So thank you all very much again, and we look forward to seeing you at another EMBL-EBI webinar in the future. So thanks everyone. Bye.